What's up, y'all? I am back with another repair video. How's everybody doing? It's Monday, so I hope everybody's having a good week, good start to their week. It was in the high 80s today here in Philly, so unseasonably warm for late April. But that's the way it goes in the Northeast. Our spring is really just, it gets very hot, then very cold, and before you know it, summer's here. I guess it keeps things interesting, so I guess that's a positive there, but yeah. But anyway, so I'm going to be doing this video on this equipment that I have right in front of me. These Invitrogen, which is the manufacturer, which is a subsidiary of Thermo Fisher. It's the Invitrogen Countess II, and we have two of them right in front of us. Okay, so they are cell counters, and they basically count cells. All right, so the way these work is you have this chamber here where you would get a slide like this. All right, so you would pipette your sample of cells into this slide. You would stain it with a reagent called, I think it's trypan blue. So you'd stain the cells, and then you would pop it into this chamber. All right, and then you'd pop it out. Now these work kind of like a digital microscope. All right, so I can kind of show you what's going on back here. All right, so there is the chamber right here. That's where the slide goes into. You have the light source up top. All right, so when you put the slide in, it basically activates the light source, which then is directed down onto the directed at the slide, but that image is directed down here to this mirror, which is then directed there, and it is directed to this is the detector over here, which connects to the main board. Okay, so this stepper motor here can move this mirror up and down to adjust the focus. All right, and that's basically how these work. Now, again, that's the main board there, which, you know, you've got some microcontrollers. There's one down here, there's another up there, and then back there is the complex programmable logic, or FPGA, I forget which. And yeah, I mean, there's not really too much that goes wrong with these. They're pretty reliable pieces of equipment. I rarely have to service them. I just do an annual PM of them, where I'll just clean the optics, I'll grease that lead screw, and yeah, I mean, one thing I've seen go wrong with these is, so there is this, you can see it right here, there is this clasp that is for the chamber, the slide chamber, and when you pop this slide in, this clasp will lock the chamber in place, the slide in place. And to release the slide, you have to press it for the clasp to release it. So it's one of those catch grab type clasps. I mean, it's literally the same thing that you would find in a drawer or a cabinet. You can get these anywhere, but when people don't press on the slide, they try to pull on it, you can break this, and then you've got to take this whole thing apart and replace it. But that's really the main thing I've seen go wrong with these. So yeah, so we can talk a little bit more about the fault that I was dealing with, that this video is about, and it was an issue with this guy booting up properly. It just wouldn't boot up. So what I'm going to do is I'm going to power both of these on, to kind of show you what was going on. Okay. Now you can see this one's already starting its boot up process, and then it'll get to this display. It says Countess II automated cell counter. All right. And it goes away. Oh, now this window comes up. And then it's ready. Nothing going on here. Nobody's home here. But yeah, so that what was going on is it wasn't booting up properly. So it wasn't doing this, but it would basically get to the black screen where it says Countess II, and that screen would either get stuck there or it would advance to the next screen, and then it would repeat the whole process over and over again. Okay, so I had never seen one of these do that before, and so I was a little bit stumped, and so I started looking at, was this thing getting the proper voltage? And I started looking at this input jack. Was it loose or something? That seemed to be okay, although I will say, interestingly, there were a couple times where during the boot up process, it wouldn't boot up at all, and you could see this light was very dim and it was kind of flickering, and you could kind of hear a little bit of a buzzing. And so what was happening is this main board has some voltage supervisor ICs that will check for under voltage, over voltage. It's a protection device, and that IC for some reason was getting tripped, and it had nothing to do with the power supply or anything like that. So that was kind of throwing me for a loop, but I did end up taking the main board out, which requires the display to come off, and also the optic bench, which is this whole black piece that has to come out just to get this main board out. I did check the RTC battery, which you can see right there, yeah, I was really struggling to find anything. I was probing the board with my oscilloscope and multimeter, and I was really hitting a wall. And then I noticed this SD card sticking out right there, okay? And because I really wasn't sure what else to try, I decided to take an SD card from a known working Countess and pop it in, and sure enough, it booted up, which I thought was interesting because I assumed that SD card maybe was just additional memory. What could possibly be in that SD card that would affect this thing from booting up? And sure enough, that was not the case. This SD card is not for additional memory. It acts kind of like the hard drive to this device. So this human machine interface, or HMI, it is a Linux-based system or OS. And so the OS, kind of like Windows on your hard drive, is in that SD card. And so I decided, well, I'm going to need to clone one of these to get this thing back up and running. And I thought, well, how hard could that be? Just take the SD card, get a SD to USB adapter, copy all the files on it onto my PC, put all those files on a new SD card, and we're good to go. And it actually didn't end up being that easy, because it's a Linux OS. And again, Linux is just a OS, just like Windows. It's just a different type. But the SD card uses a different file system that is not compatible with Windows or Mac. And that made cloning this SD card a little bit more difficult. And that's kind of what I'm gonna show you. That's what I'm gonna show you how to do in this video. Okay. So what we can do is I can we're gonna go over to another PC and I'm gonna walk you through that process. So let's get started. Okay, so we are now at the PC that I'm going to show you guys how to do this on. Now, a couple things you should know. This is only going to work if you have if you have at least two countesses. One that's known to be working, and then you've got the one you're trying to repair. Because you're going to take that SD card from the known working one and clone it for the one that you're trying to repair. Now, if you've only got one, there may be some information in this video that might help you to repair that SD card or figure out why it's corrupt or why it's not booting up. But this is really geared towards a lab that has at least two of these countesses, so you can clone the SD card. All right. So right now I've got this software opened up. It's called DiskGenius. This is actually free to download from online. I did try at least one other SD card or disk management software, and it just didn't. It wasn't free, and it just didn't have the tools or capabilities that this software does. So I highly recommend just going with this one. You're also going to need a way to connect both SD cards to your PC at the same time. That's likely going to require two SD to USB adapters. Those you can find anywhere, Amazon, they're relatively cheap. So just a couple things before we get into this that you should be aware of. But yeah, so right now, if you look at the left hand side, you can see the disk for the PC, the hard drive for the PC, and then you've got the two SD cards. One is the known working one, and then we've got a blank one here. This is actually the original SD card from that countess that was having issues. I've just completely wiped it, and we're gonna use this guy to kind of walk you through how to do this. All right. So the first thing you're gonna want to do is we're gonna want to partition this brand new SD card, and you got to match it to the original. All right, so this isn't going to be just, one click of a button, you've got a cloned SD card. It's just not going to work. So let's start with each drive. The first one is the FAT32 drive, so let's start there. And you're going to want to just reference each one as you go. So we're going to need some information here. So we're going to need the cluster size, which is 512. The capacity, we're going to just do a rough estimate. We're going to narrow. I'm going to show you guys in a second why that is, but just so for example, we're just going to pick 71 megabytes just to create the partition. So yeah, let's start with that one. So you're going to go to partition up top, create new partition, and it's already the file system type we need. And so size of partition, again, it was 71 megabytes. The cluster size was 512. And then for some reason this changed. Oh. Alright. So that should be good. We're going to click OK. And then we're going to do the next one. And again, just reference the one you want to do first. So this is now, we're looking at the file system ext3. This is the Linux based file system. Alright. And the capacity is roughly 267 megabytes. Cluster size is 1024. So you're going to want to remember that when you create the next partition. So it's going to be a primary partition, just remember that. It's ext3. Cluster size change. And then it's roughly 267 is the size. Okay, so we got that one. And then the next two are the exact same. All three of these are the same as far as how they're partitioned, so we can just do these real quick. Okay, so now we've partitioned the new SD card, but we've got to do a few more things to make this work. And I'm going to show you guys those things in a second. So we're going to be, we're going to click on the first one, and we need to click on here, modify partition parameters. Okay, and so you're going to see here, it's asking you for all of this information. The cylinder, beginning head, beginning sector, ending cylinder. What is all this? What does this mean? And so, again, I am not a PC software guy by any means, but just to give you a little bit of an overview, this is how we are addressing the physical sections of the hard drive. And this is a bit of a diagram showing you that. All right, so you've got the disks here, and you've got this red slice, that's a sector. The yellow is a track, so that's where the heads are reading. All right, and then you've got the cylinder, which is this blue portion that all of these disks are sitting in. Okay, or sections of the drive so this gives you kind of an idea of what these parameters mean. All right, so it's basically just identifying the location within the hard drive that these files are going to be going. All right, and it's very important to get that down correct. Otherwise, the SD card isn't going to be read properly, or files are going to get corrupt, or the drive is going to be corrupt. So this is very important. So what I would suggest you do is, let's cancel out of this real quick, is go to the working one, and then you have all this information here right in front of you. I would suggest writing that down or taking a picture with your phone, so that way you can have it in front of you while you get these partition parameters for the remaining, for all the drives correct. And so I've done that here. I've written them down. So we're going to start with the first one again, and you're going to right click on it, go to modify partition parameters. All right, and the system identifier is 0B. That's the same. Beginning cylinder is 0. I'm just not going to say them all out loud. You guys can just kind of see me type them in. Oh man. Oop. Okay, so that is the first one, and you can see the capacity right here. You can see how it's changed. So now it's 70.57 MB, and that's why I just was saying earlier, we're going to ballpark it, because once you enter all these parameters in, it's going to give you the exact capacity as the original. Okay, so we've got that down. So that's the first one, and we're just going to move through and do the remaining ones, and it's pretty much the same deal. All right. And yeah, so you can see now it says 266.7, just like the original. Now, for some reason, this one, it changed from 83 to 18. I'm not sure why it did that, so I'm just going to go back and modify it and then change it. Sometimes, for some reason, that'll happen. Just make sure that, it's not doing any funky stuff. So, yeah. Okay. All right, so now you've got all of them partitioned exactly the same. Just gonna quickly double check. So click on your working SD card. Make sure everything matches up. Another thing is right here it says attribute. So you're gonna make sure that the first one is active. So I think to do that you go to see. Okay, mark partition as active, so you're just gonna right click on it. It's already done, so that's why it's it's all gray, but yeah, right click on it to do that. So make sure the first one is marked as active. And then once you have all of that done, and again, make sure, just do a quick check, make sure everything's the same. All right. But yeah, once you have all that done, we're going to click on disk and save partition table. Click yes. Yes. It's just going to do that. Okay, and now, oh yeah, now everything's catching up on your PC. It's going crazy because all, you know, yeah, you've got all these disks that are now, or you got all these drives that are now in that Linux-based file system. So yeah, that's going to happen. Don't be alarmed by that. Just exit out of all that. But yes, now we are ready to clone each partition. Okay, so doesn't matter really which one you start with, but we can start with the bottom one here. You're going to click, going to right click on it, and then you're going to select clone partition. All right. Now it's going to ask you which one is your target, so you're going to match it up with this last one here. All right. So that's the one I'm going to click on. I'm going to click OK. And then because you've gotten all of the sectors, all of the partition parameters locked in, I'm not sure if it matters which one you click do here, but I would just do copy valid data sectors only. I would just select that one, and then when it's finished, you have these options here. Now, for some reason, every time I do the clone a partition, my PC shuts down regardless of what I put in here. But I've just been pressing standby regardless, just because that's what worked the first time. So that's what we're going to do here, even though it'll probably still shut down. And then I'm going to click start. I'm just going to click OK. All right, and watch here. Yep, so the PC shut down. All right, so we're going to have to do that for each one. I'm not going to do every single one here, but we'll connect back up when it's finished. Okay, so this was after my PC. I restarted it. It's still up and running, and so you can just click complete, and then we'll move on to the next one. Again, like I said, I'm not going to show you each and every one of these, but we'll just do the next one here. Again, you're going to just right click on it, go to clone partition, select this one. Just again, you're matching them up. We're doing this one, we're cloning this one, so we're going to put it here. All right, click OK, and then copy valid sectors only. And of course, you could probably just leave it shut down, but that's, again, just being a little bit superstitious here. All right, click start. And it's going to shut down again. Yep. Okay, so I just finished the last drive and the power cycled the PC, and now you can see everything matches up pretty nicely. All right, so you're just gonna, I would recommend just doing a quick check, making sure everything matches up. Another thing you can do is, so like I had mentioned, I did purchase a Linux reader software, and you can use that to just verify that the files are matching up. Everything kind of looks the same. And so far so good. Okay, so I mean everything looks good. Another thing you can double check is just make sure you can access the FAT32 drive from your PC. Just as a quick check. Well, alright guys, there you have it. That is how you can fix a booting issue with one of these cell counters. Again, definitely first thing you should check is that that SD card without a doubt. And I hope you can use this video to repair one of these, even if you don't have more than one. Maybe there'll be something in this video where you can at least get a look at how a working one is partitioned, how it's formatted, and that might be able to help you out. But yeah, hope you guys found that interesting. I know these videos might not be the most entertaining, but one of the reasons I made this channel was to really help out others in a situation like me who don't have the resources to repair these. Maybe they don't have a dedicated in-house engineer, because this stuff gets expensive. I mean, it's ridiculous how much these companies who manufacture this stuff will charge for relatively easy repairs. I mean, I had somebody recently who commented on one of my videos I did on repairing an ultracentrifuge, where just to replace an RTC battery, which is basically the CMOS battery that keeps your device, it keeps the date and time the same, accurate when you're power cycling. Relatively, it's just a coin battery, easy to pop in. They're gonna charge this person $3,000 just to replace that battery. So it's this kind of stuff that I want to show you. Which, speaking of RTC batteries, there is one in these units as well, and I had shown you the main board earlier. So if you're having, these also could potentially cause booting issues, but really the main thing is the date and time isn't going to be correct. Okay, so, but again, we're talking about these manufacturers charging thousands of dollars for simple repairs like that. And that's kind of what I am trying to empower the people who watch this channel, or anyone, to fix this stuff themselves. Because not all of us are Mercs or GSKs or other companies that have billions of dollars to buy new equipment. For the startups out there who are trying to get themselves up off the ground, having this information can really save your budget. So that is a wrap on these. I'll catch you guys next time.